This is our first video for SLO 9, hypothesis testing. For this SLO, we'll be looking at chapters 9 and 11 in the books. Today we're going to be covering sections 9.1 and 9.2, so make sure to read both of those. Now, last time we were using confidence intervals to create sort of a window of estimating the true mean, the population mean, based off of our point estimate, right, the sample mean. But what if instead of coming up with that range, we just sort of had a belief or maybe a prior statement that the population mean already was a certain value, and we just wanted to go out and see whether there was evidence that that value was really correct? Well, to answer that question, we use hypothesis testing. All right, now first we're going to define some terminology. And just to be clear, I'm doing this a little bit differently from the book. I'm defining some terms now that they define in section 9.1, but there are other terms that they define in 9.1 that I'm going to wait until a little bit later in this video to define. Okay, so please read both sections that correspond to this video. So let's go back to chapter 8, right? We considered Lenovo laptops. They claimed that their laptops had battery lives of 7.5 hours, right? In other words, that ThinkPads have a mean battery life of 7.5. Now, again, by the way, this is completely made up. Not speaking for Lenovo or anything. So we would expect a random sample of ThinkPads to have a mean battery life of, I would say, approximately 7.5 hours, right? Why might it not be exact? Well, just because stuff varies. Maybe one battery was, made a little bit better than the other. There's just always going to be variation, etc. Right, there's usually some variation in product. I'll just say in product quality. Some batteries might have a little more or less life. I would say just based on random, I guess I'll just say variation in manufacturing. Right. Now, that said, we wouldn't expect huge deviations from the mean, especially when we took a sample mean of a large number of them. Okay? So I'm just going to write that down. We wouldn't expect lots of difference between our sample mean or our point estimate x bar and the population mean mu, right? Some, but not much, and less as the sample size grew and grew, right? Assuming, of course, that it's a random sample, right? So last time, remember, we took a random sample of 81 laptops. We found their battery life to be 7.3 hours. And remember, we assumed, somewhat unrealistically, that the standard deviation of the battery life was 0.6. Remember, it's sort of unrealistic that we wouldn't know the population mean, but we would know the population standard deviation. But anyway, just assuming this for right now. So, right, we're assuming mu equals 7.5, maybe. But I guess we do also have that n equals 81. We also have that x bar equals 7.3. Oh, sorry, that's 7.3. And sigma equals 0.6. Okay, so we've got that. So the question is, does the evidence support that, like from our 81 laptop sample, does that evidence support that ThinkPads have a 7.5 hour battery life. And you can have your own opinions about this. You can think what's reasonable or what's not. I'll just say, I don't want to say try it. I'll just say, what do you think? Right? Say whatever you want here. Okay? We're going to do a more formalized method and have it with a certain standard of, what we consider to be enough evidence. Okay? So what we're going to do is we're going to use a hypothesis test, which is a statistical method that determines the statistical significance of the sample mean, assuming a certain population mean. So here's what we do. First, we state our hypotheses. Right? So I can move that over a little bit. There we go. Right? So the null hypothesis. What? Oh my goodness, what's happening? The null hypothesis, which is known as H naught, is the current accepted value with whatever we're talking about, right? This is a general definition, right? The alternative hypothesis, or, the alternate hypothesis. I think Minitab calls the alternative. I've seen this written as HA, and I think I might refer to it as HA in the notes, but the book and Minitab call it H1, so I will call it H1. Either is fine, though, right? The alternate hypothesis is, well, not the current value, right? It might be greater than, it might be less than, it might be not equal to, right? It will be clear from the context whether we're talking about less, more, or just not equal to, okay? So what are our hypotheses for the battery life? Well, the null hypothesis is, I'll say, ThinkPads, or is it ThinkPads or IdeaPads? Yeah, ThinkPads, okay. Have a mean battery life mu equals 7.5 hours. Okay, standard current accepted value. What's the alternate hypothesis? The alternate hypothesis is ThinkPads. Well, this is sort of up to us, right? You could say, based on this, I guess we could say, does or does not suggest, I guess I'm not really specific here. So let's just say, ThinkPads have a mean battery life. So I wasn't very specific about this, but I'll be more specific in the future. Mu less than 7.5 hours. Okay? That's the alternate hypothesis. Okay? So now what we're going to do is we're going to find the standard. This is how we actually conduct a hypothesis test. It's sort of analogous to the confidence interval stuff. It's just we're conducting a test instead of creating an interval, right? So create the standard error, right, which is, I might call it the SE, right? And our standard error is the same thing as it was before, right? It's sigma, let's try that again. Sigma over root n, which equals 0.6 over the square root of 81, which is 0.6 divided by 9. 0.02, let's see what that is, right? 0.6 divided by 9, 0.0667. Okay, right. So we'll just say it's 0.067. 0.067. Okay. Right. We then find the z-score, of our sample mean within the normal distribution. Now remember, we're talking about z-scores and normal distributions because we are unrealistically assuming that we know what sigma is. When we don't know what sigma is, that's when we had to talk about critical values, t, distributions, blah, blah, blah. But for right now, easy peasy, z-scores, normal. Remember, z equals x bar minus mu all over our standard error, right? Not just standard deviation, standard error. All right, and in this case, that's going to give us, was that 7.3, if I could write, minus 7.5 divided by 0.6 over square root of 81. And that boils down to negative 0.2. Don't forget that negative. Divided by 0.067. And that winds up being negative 3 when you do it out. Okay, so a z-score of a nice, even negative 3. Okay, now if you wanted to use the tables as provided in the book, that's no problem. You just go to the book, wherever we are, we're over here. Right, you go to table, remember it's under here, tables A2 and A3, it's table A2. You find the z-score, negative 3, for 0.0, and you just line it up, and you say, oh, that's 0.0013. Okay? And you just write that number down. That's called your p-value. Or you could use Minitab, right? So let's see what we do here. Basic stats. Here we're actually going to go with one sample z, and we're going to use summarized data. Our sample size was 81. Our sample mean was 7.3. The known standard deviation was 0.6. And yes, we are performing a hypothesis test, and our hypothesized mean is 7.5. Now we're going to go to options. Now we don't worry so much about the confidence level right now. We're assuming that the mean, right, our alternate hypothesis, see they call it alternative, is that the mean is less than. Remember, I just sort of specified that ahead of time, right? Ignore that, ignore the whole confidence level thing for right now. We'll talk about that a bit later. But when I press OK, see right down here, the z-value is negative 3, p-value is 0.001, right? So same thing as in the book. Okay. Right. So anyway, using the standard error, we use Minitab or Table A2 to find the p-value of x bar, which is the probability that we would get a value less than x in this case, or sorry, less than x bar in a random sample of size 81. Okay? And here, let me actually just take a quick picture of this. Oh, I guess I took a purple one. Oh well. Let's weird. I will trash that guy and use this guy, right? Let's crop this, and we get that, and we're good. And we're just gonna paste this in here. So we'll say the z-score z equals negative 3 corresponds to the p-value, p equals 0.0013, I guess, from the book, right? 0.001, okay? What that means, let me just draw this out really quickly. This means that on the normal curve, if this is our mean, right, sorry, if this is our, like on the standard normal curve, so to speak, you could say that our mean has a z-score of 0, z is corresponding to negative 3, and that area right there is 0.001. Very, very small, right? I did not draw that to scale. Okay? Right, now remember, this is the standard distribution, standard normal distribution, right? All right, let's see. So suppose we say that a p-value of 0.05 or below is unusual enough that we don't believe the null hypothesis is true, right? But a p-value of 0.05 or greater suggests that h naught might be true. So since p equals 0.001, which is less than 0.05, we state the following. I'll write it again. Since p equals 0.001, which is less than 0.05, we reject the null hypothesis that the mean battery life i.e. that ThinkPads have mean battery life of 7.5 hours. Or I should say of 7.5 hours. All right. So we then conclude ThinkPads likely have battery life less than 7.5 hours, right? Now, just want to say what I said and what I didn't say. We said we reject the null hypothesis. We did not say that we accept H1, the alternate hypothesis. You write this, you're wrong. That is not what we do. We do not accept this. Please do not write that. That is not proper language in statistics. It's sort of like guilty, not guilty kind of thing, right? We never say innocent, right? We just say we reject H naught, or we fail to reject H naught, right? We reject the null hypothesis or we fail to reject the null hypothesis. Okay? So anyway, that was a long and drawn out example. Here's what we do in general. We state our null and alternate hypotheses. We find the standard error. I guess I should find, maybe I say, it doesn't really matter the order in which you do it. No, I guess it does, right? You should find the standard error. Find the standard error, which is sigma over root n, and then the z-score, z equals x bar minus mu all over standard error. Then you find the p-value corresponding to your z-score. Determine your level of significance. That was the whole alpha equals whatever. And we call that alpha. Let me write that over here. Let's try to shift this over a little bit. Alpha. And compare p and alpha, right? And now if p is strictly less than alpha, then reject the null hypothesis. If p is greater than or equal to alpha, although I've never actually seen it equal to alpha exactly, then we fail to reject H naught, the null hypothesis, right? And then state the conclusion, right? The way I was like, oh, it looks like the battery life is less, right? So let's take a look at one example, okay? Looks like the mean price of a home in Denver in 2018 was that much, okay? We randomly sampled 50 homes in 2019 and found a higher mean price, right? Now let's take a look. Assume that the population standard deviation is sigma equals 150. Suppose that we know that somehow. Can you conclude that this price differs? Now, this is a little different, right? This just says differs, right? i.e. not equal to, okay? So let's see. We're going to first state our null and alternate hypotheses, right? We're going to say, okay, mu equals, I guess we'll say, $522.8 thousand, right? Our alternate hypothesis is that mu does not equal. Okay? And if you want, you can write it out in words, you know, mean housing price does not equal blah, 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 blah. Okay, we're just going to stick to that right there, okay? Next, we're going to find, so we could find our standard error. I think that's a good idea, right? We will need that even if we use Minitab. So I guess we should say n equals 50, right? So the standard error is going to equal sigma over root n, right, which is 150 divided by the square root of 50, which is the lovely value of, I don't even know what it is, let's see, 150 divided by the square root of 50. 21.21. Let's go with that. Right, and that's dollars if you care, right? Dollars. Okay. So now we're just going to use Minitab. I'm just going to write use Minitab. So if we use Minitab with our numbers, right, we've got 553.3. Okay. All right, so again, basic stats, one sample Z. Sample size was 50. Sample mean was 553 point, what was that? 0.8? No, 0.3. 553.3. Known standard deviation was 150. I guess we don't need to find the standard error. Never mind. I guess we don't need to know that. But we are performing a hypothesis test. And what did they say the housing price was? 522.8. Right, and our options here. So confidence level, it's just 1 minus your significance level. But we are hypothesizing that the mean does not equal, so please change it to that. And then we get our answer, right? All right, so we have that. I'm just going to crop this. Let me just keep this here just because it... right, look at it, gives us a confidence interval and everything. Very nice, right? Even though we don't really need that, right? Oop. We're going to post that right here, paste that right here. Right? So anyway, I guess we didn't really need the standard error. Let me actually erase that just because we don't really need that, as it turns out. And we're just going to move this stuff up here. And look what we get. Okay? So our p-value... is 0.150. So we say since p equals 0.150, which is greater than alpha, which equals 0.05, we fail to reject the null hypothesis. So we don't, in English, right? Oh, we don't have enough evidence that the mean 2019, right, because we found the sample in 2019, housing price in Denver is not 522.8 thousand. Right, now again, I don't love the double negative, right? We don't have enough evidence that it's not that, but we have to say it that way. We fail to reject, right? That's how this works, okay? That's all we've got for right now. There's another video coming up.